geometric sequences. The nth term formula. So we have this sequence, and we can see that the first term is 5, so a equals 5. This time we have a multiplier between the terms. It's called the common ratio, and to work it out you take any two terms and you take the term on the right and you divide it by the term on the left. So 10 divided by 5, 20 divided by 10, 40 divided by 20. That gives a common ratio represented by the letter R. This is the nth term formula for a geometric sequence, and it needs to be memorized. It's not given in a formula book, and if we substitute in a equals 5 and r equals 2, where n is the term number, like n equals 1 is the first term, n equals 2 is the second term, and so on, we get this nth term formula for the sequence above. So the first term, n equals 1, so we substitute in n equals 1. Second term, n equals 2. 10th term, the kth term, term k, is this value in the sequence. So we have our nth term formula, and we make it equal to the value that's given here, and then we solve to work out n, and if n turns out to be an integer, then this value is in the sequence. Divide by 5. Now we're looking for n, and n is a power, so we can use logs to solve this, and the base here is 2, so I could use, for convenience, logs to the base 2. So I've taken logs on each side to the base 2, and the n minus 1 is a power, it comes to the front. When we're doing logs, make sure it's in brackets. Log 2 to the base 2 is 1, so we have n equals 20. From the calculator, this value here is 19, so 19 is equal to n minus 1, so n was 20. I just added in an extra step for clarity. So it's an integer, so the value that we started with is in the sequence, this value. It will appear somewhere in this sequence. Example 2, what's the nth term formula for this geometric sequence? Okay, so a is 2, and we can see we're multiplying by 2, so the common ratio is 2 between the terms. General formula, substitute the values in. Now this is 2 to the power of 1, and that's 2 to the power of n minus 1, same base, so when we're multiplying we can add the indices to get a more simplified formula. Okay, work out the value of the common ratio for these terms. So if we take any two terms and we divide, so if I take these two terms, it's the term on the right divided by the term on the left. So the common ratio is 0.25, or a quarter. Okay, part B, a different geometric sequence, and if we do the same again, if we take any two terms, so I've taken the first two terms here, the term on the right divided by the term on the left, so the common ratio is minus 2x. And if we do the same with the other two terms, so if I was to use these two instead and divide, we get the exact same common ratio, and it should be the same if it's a geometric sequence. Okay, example 4, the second term and the fourth term is given. So here n equals 2, n equals 4. find the 11th term. Now we can work out the 11th term when we know what the first term is, we know what the common ratio is, and then from there we can write down a general formula for the nth term, and then from there we can work out the 11th term. Okay, so general formula, and we need to use this for each of these. Okay, substituting values in. So the 4 replaces the un like this. We don't know what a is, we don't know what r is, but n is 2, second term. N equals 2. Do something similar on this side. Simultaneous equations. If I just divide them, it's quite convenient to divide them. The a's will cancel. And some basic indices here. And we have an even power, so when we square root you get plus or minus. But it did say down here that r is positive, it's greater than 0. Because r is greater than 0, we need to discard the minus root 2 solution. And if we substitute the value of root 2 into here, so then a is equal to 4 divided by r, and 4 divided by root 2 is 2 root 2. Nth term formula, we know what a is, we know what r is, substitute those in. It's the 11th term that we're looking for, so n equals 11. Simplifying the indices, changing from surd form to index form. So this part we've got 2 to the power of a half, which is root 2, to the power of 10. You multiply the powers together and that will give us 2 to the power of 5, which is here. But now we have 2 to the power of 1 times 2 to the power of a half times 2 to the power of 5. Same bases, bases 2 throughout. We can add the indices together. And if I write the final answer in surd form again, we've got 64 root 2. 2 to the power of 6 is 64, and 2 to the power of a half we know is root 2. What's the value of x? Okay, so in this example, to work out the value of x, we do know that the common ratio between any two consecutive terms, so if you divide these two terms, you will get the exact same answer as if you divide these two. The term on the right divided by the term on the left. The term on the right divided by the term on the left. And we can make these two equal to each other because they both represent the same thing, which is r. Solve the equation, quadratic, and we know that x is greater than 0, so x equals 6. Example 6, again we have an arithmetic sequence and we're looking for the first term to exceed 1 million. Not the sum of terms, we're not looking at series, we're looking at sequences, the first term. So if a is equal to 3, the first term, you can see we're multiplying by 2 to get from one term to the next, so the common ratio is 2, and we want to solve this. And un represents any term in the sequence. So we have a general formula for un. If we substitute the values that we know into this formula, so now we have to solve this inequality. Dividing by 3, take logs to the base 2, and again when you're taking logs you can use the power rule for logs, the n minus 1, put it in brackets and move it to the front like this. So we've taken logs on each side. So when you take logs, it would be like this first, and then you do this. Okay, to get n, we need to get rid of this log 2 base 2, which is, we know it's 1. So from the calculator, the value of this log is about 18.3. Add 1, n is greater than 19.3, so you round up, n equals 20. So if I put in n equals 19, so for the 19th term in the nth term formula here, the value is less than 1 million. And if I put in n equals 20, this value exceeds 1 million. For practice, try these questions.